Hello and welcome to the Further Maths OCR Pure Core videos. This is polar coordinates and this is video 1.2, sketching polar curves. So a sketch of a curve, as you know from your maths work so far, shows its shape and the important points. The best way to do this is to work out the coordinates of a few points on the curve and then connect them. When we're looking at polar graphs, sometimes it's quite useful to look at the behaviour of r as theta changes, so you can get an idea of what your curve is going to look like. Particularly what you want to look at is values of theta for which r is 0 or is a maximum or a minimum, so that you can look at how it's varying. You can also use a graphical calculator to plot the graph and then draw your sketch from it, but it's really important that you are able to recognise what type of graph you're looking at, have an idea of what it's going to look like, and be able to sketch it as well so that your graphical calculator can confirm it, not just blindly use your calculator without any idea of what it should look like. Okay, so we're going to look at these three curves here. We're going to look at the curve of r equals 4, we're going to look at the curve of r equals 2 times 1 plus cos theta, and we're going to look at the curve of r equals 3 plus sine 2 theta. What I'd like you to do now is pause the video and just have a little think about these three curves and what shape and what kind of behaviour you might expect from them. Okay, so we're going to start now with r equals 4. Now, what's important to note here is that we don't have theta included in this. So in fact, we're just going to be looking at all the points that are a distance of 4 from the pole. So I can draw a few in there. Theta isn't changing, so whatever theta is, it's going to be the same. So hopefully you have an idea of the shape that this is going to be. And it's actually just the locus of points that are 4 away from the pole. Okay, so it's worth having a look at one of the GeoGebra files here, and this is where we've got r equals 4. We can change that value and you can see that all we get is a circle. It continues to be a circle, but with a different radius. We can move this point P around, and as theta changes, r just stays the same. Okay, now we're going to look at this curve, which is r equals 3, 1 plus cos theta. Now what we're going to do is look at a couple of key points and think about how theta is changing. So if we look first of all at where theta is 0, then r is 6 at that point. If we think about pi by 2, r at that point is 3. And if we think about pi, at that point r is 0. So we can see that r is going between 6 and 0. If we go round again to 3 pi by 2, we find that r is again 3. And if we go around to 2 pi, r is going to be 6. So we're now going to look at what this curve looks like. And it looks like that. It's called a cardioid, and we can see that it oscillates, r oscillates from 3 by plus or minus 3. And we can see here's the sketch there. If we change some of our variables here, we can change this curve. So we noticed that r oscillates a distance of 3 from, plus or minus 3 from 3. So if we change a to, for example, 4, we can see it does the same, but plus or minus 4. Okay, now if we go back to 3, have a look at what happens when we change b, we can see that changing b changes where the position here is. It also changes the shape of the curve. Okay, so it's important that you have a go at some of these on GeoGebra and have a little play around and see what changing things does. Remember, for OCR, r less than 0 is not defined, so you may sometimes find parts of curves drawn that you would not have drawn in your exams. Okay, so the final curve we're going to look at is this one, r equals 3 plus sine 2 theta. So we're going to look at, again, some key points, think about what's happening with r. So when theta is 0, r is 3, theta is pi over 4, r is 4. When it's pi over 2, r is 3, 3 pi over 4, r is 2, and when it's pi, r is 3. So think about what's happening here. We're coming in and out from 3. Let's have a look at what that looks like now. Okay. So we can see again that curve drawn in GeoGebra. As I've mentioned before, when r is less than 0, the OCR convention is that it is undefined. So you may find when you're drawing these curves in GeoGebra, you get some branches that are undefined. For example, if we look at this here, which is a rose curve, you can see we've got 4 petals here, but in fact 2 of those are where r is negative, so in terms of OCR we'd only want 2 branches shown, only 2 petals shown. So that was a video on sketching polar curves. Next time it will be 1.3, converting between forms.